Hey, this is a little different look to our video for a lesson. Let's see how this works. This is lesson 13.1. It's found on page 568 in your textbook. It's chapter 13, Graphing and Writing Linear Equations. Well, linear equations, the key idea, a linear equation is an equation whose graph is a line. Okay, so it's going to be a straight line. I know that's redundant, but just so that you know it's not going to make a curve or a wave or anything like that. It'll be just a line. The points on the line are solutions of the equation. So there are infinite number of solutions. You can use a graph to show the solutions of a linear equation. The graph below represents the equation y equals x plus 1. So the first thing we do is we make a table, an XY table, and then we have a third column which is for XY. Remember, an ordered pair, XY, is used to locate a point in a coordinate plane. So we get to plug any values we want in for X. We plug in this example, -1 for X. And if you put -1 in for X, looking at our equation, that would make it -1 plus 1, which is 0. So Y would equal 0. If we put 0 in for X, then y equals 0 plus 1, which is 1. And if we put 2 in for x, then y equals 2 plus 1, which is 3. That gives us our three ordered pairs, -1, 0, 0, 1, and 2, 3. When we graph those, they will look like this graph over here. We put the 3 points on there, and then we draw a line through them. If we always we try to plot 3 points, and when we draw our line through those, if it's not straight and it doesn't go through all of them, then we've done something wrong, which is why we do 3 points. For example 1, graphing a linear equation, they give us y equals -2x plus 1. The first step is to make a table of values. Now this table looks a little different because we not only have an x, a y, and an ordered pair XY column, but we also have that column they put in between our X and Y, which is our equation. Y equals -2x plus 1. Well, they did that because it's not just a one-step equation, which you can just do mentally. It's a two-step equation, and we want to keep things nice and ordered here. So for our first row on our table, we put a value of -1 in for X. That makes our equation y equals -2 times, instead of x, we have it times -1, and then plus 1. When we solve that, -2 times -1 is +2, plus 1 is 3. So our y value is 3, and our ordered pair would then be -1, 3. And we put 0 in for x, and -2 times 0 is 0, plus 1 is 1, so our y is 1. Our ordered pair for that would be 0, 1. And finally, we put in a value of 2 for x. When we put in a value of 2, we get -2 times 2, which is -4, plus 1, which is -3. So our ordered pair would be 2, -3, which means when we have an x equaling 2, our y, of course, equals -3. We plot those 3 points, those 3 ordered pairs, onto our graph. We draw a line through them. The end. Put little arrowheads on your line. The next key idea is graphing horizontal and vertical lines. On the left here, it says the graph of y equals b is a horizontal line passing through 0, b. And what that means is no matter what we put in for b, so y could equal 4, or y equals -3, or y equals anything that is just a constant, will give us a horizontal line that goes through where y equals that number, let's say 4. That would be a green line going through y equaling 4, because it doesn't matter what x is, because it doesn't affect our equation. On the right-hand side here, we see a vertical line, the graph of x equals a, where a will just be any constant. So if x equals 3, it would be a vertical line passing through 3, 0. And then that line extends, of course, forever up and forever down, but it goes through the x-axis at x equals 3, or whatever the constant might be. Example 2 works through 2 such problems. Example 2a, graph y equals -3. The graph of y equals negative 3 is a horizontal line passing through 0, negative 3. So you just draw a horizontal line through that point. Remember, no matter what we put in for the x value, y would always equal negative 3. And then example 2b, graph x equals 2. The graph of x equals 2 is a vertical line. It passes through 2, 0. So you draw the vertical line that passes through 2, 0. So let's work on these on your own. Number 1, from page 569, it says y equals 3x. And we're going to make a table for that. And when we make our table, we're going to make our table x, y, and then over here, we'll put our coordinate pair, which is x, y. All right, so we can pick any values we want for x. I could pick 1 million, and 3 times 1 million would be 3 million for y. But I do not want an ordered pair of 1 million, 3 million to have to put on my coordinate plane. I could also put negative 7/8 in for x, and then get negative 21/8 for y. Why would I want to do that to myself? I don't want to have to graph those. So we're going to pick some values that are nice and easy. 1, 0, and negative 1 are my go-tos here because they stay very central on our coordinate plane. Well, if x equals 1, then this would be 3 times 1, and 3 times 1 is 3. So if x is 1, y is 3. So one of the points that'll be on this line would be 1, 3. If x is 0, 3 times 0 is 0. Y is 0. So this is going to go through the origin because 0, 0 is one of the points on that line. And if x is negative 1, 3 times negative 1 is negative 3. So I will get negative 3. So negative 1, negative 3 would be another point. And when we plot this on our coordinate plane, it's going to look like that, right there. Number 2. Y equals negative 1/2 x plus 2. Now this was just a one-stepper up in number 1, but in number 2 we have a two-step equation here that we're going to have to figure out, which isn't horrible, but we have to make sure that we're doing this right. So we'll make our table a little different now. X. And then we're going to put our equation in here. Y equals negative 1/2 x plus 2. Figure out what y would equal. And then our ordered pair. So x, y. So again, we're going to pick some nice easy values for x to put in here. The first thing we're going to do with any x value I see is we're going to take a half of it. So I'm not going to use 1 because then that would give me a fraction. So I'm going to use even numbers to try to make this easier. So we'll try 2, 0, negative 2. And now the reason we have this equation in here is so I can plug 2 in place of x and then solve this. So this would be y equals negative 1/2 times 2 plus 2. And it just helps us to keep it straight in our minds exactly what we're doing with this x value. So now I can walk through this. Remember, multiplication comes first. Negative 1/2 times 2. Well, 1/2 times 2 is 1. One of each as far as signs go. When we multiply, makes it negative. So I have negative 1 plus 2. Negative 1 plus 2 is 1. So my ordered pair here would be 2, 1. Here I put 0 in for x, so it'll be y equals 1/2 times 0 plus 2. Negative 1/2 times 0 plus 2. Well, negative 1/2 times 0 is just 0, plus 2 is 2. So when x is 0, y equals 2. This does not go through the origin. And our last one, if I put negative 1/2 in there, so negative 2. Negative 1/2 times negative 2 plus 2. Well, negative times a negative is a positive, and 1/2 of 2 is 1. So 1 plus 2 is 3. So our point here will be negative 2, 3. And when we graph that on our coordinate plane, our answer is going to look just like this. Number 3. X equals negative 4. Well, x equals negative 4. Notice there's not a y in here. This goes back to talking about horizontal and vertical lines. Because if I make a chart here, x and y chart, and my ordered pair, x, y, x is negative 4. Well, what about when y is 1? X is always negative 4. What about y is 0? Nope, x is always negative. What about when y is negative 1? X is always negative 4. So this is going to be negative 4, 1, negative 4, 0, negative 4, negative 1. And we can see we're just going to have a line where x is negative 4. So it's going to be a vertical line going through where x equals negative 4. Whoop. Just like that. Finally, number 4, on your own, y equals negative 1.5. And that's a lot like this one, where x equals negative 4. Here, y equals negative 1.5. Doesn't matter what x is. So we'll have our x, y, xy, and y always equals negative 1.5. If x is 1, it doesn't change this. Y equals negative 1.5. If x is 0, it doesn't matter. It doesn't influence this equation because there is no x in it. Y still equals negative 1.5. If x is negative 1, negative 1.5 for y. So our ordered pairs, negative 1.5, negative 1.5, is just going to be a line that goes through y at negative 1.5. So it'll be a horizontal line that goes through y equals negative 1.5. Just like that. Well, that concludes the lesson portion. Now, if you can go to page 570, if you have your textbook at home, or if you can access it online, and work on the odd problems. They give you the equation, you can draw a graph, or you can just go straight to the back of the book and look at the graphs they came up with for answers and make sure that that makes sense to you with the equation they give you for the problem. So just match the equation with the answer in the back of the book. And now you can go and do journal page 296, which is the journal page for lesson 13.1.